The level of dissolved oxygen, DO, in a stream or river is important to aquatic life. Look, I've included some adorable aquatic life here for you. Oh, really? That's weird. A researcher measures the DO level at 15 randomly selected locations along a stream. Here are the results in milligrams per liter. An average dissolved oxygen put under 5 puts aquatic life at risk. Oh no! Do the data provide convincing evidence at the 5% significance level that aquatic life is at risk? Okay, state. We need a ho. We need a ha. This problem is talking about means. And it's talking about means because it says the word average right here. And so your mean, your null hypothesis is always equals. And we're going to say that it's at 5 because the alternative hypothesis that we're trying to check for would be under 5 or less than 5. Sometimes it's easier to find the ha first and then work backwards to the how. Mu equals the true average, and you can say mean, dissolved oxygen in this stream. And we can only talk about this particular stream because it's just where they got the randomly selected locations. And then alpha level says 5% significance level, so alpha equals 0.05. Are there any questions about this? Anything whatsoever I can answer. Okay, great. Okay, now plan. 1 sample T test for means. By the way, really quick question. In the video that you guys watched last Friday, was the joke in there? Oh, okay. I then I have 2 jokes for you today because the one from Friday was like one of my favorites. So I just have to go back to it. Okay, anyway. Random. Randomly selected. Check. Indeed. Yep. 10%. N equals 15 is percent of all locations. I don't really know about this stream. I got to be honest with you, but I got to go on with the problem. So I have to make an assumption that at least it's long enough to have 150 locations. Okay, this is where the bummer is going to come in. Okay, any questions up to here? We're pretty solid. I'm thinking the only new thing really is that we used mu instead of p. And it's a number and not a decimal. Woo! Crazy. Okay, now, notice something about the data this time. So the whole point really of me doing this problem with you is this new stuff, but also this. You guys notice that we got a lot of decimals here. A lot of decimals. I don't actually think that's the case. I'm just trying to wake you up and make you smile. But I'm just trying real hard. Okay, now, are decimales the best thing for a dot plot? It's not decimales, is it?
No, it's not.
I know the word is actually decimal, and I was trying to make it fake Spanish. You know, like putting an O at the end of everything. No, no one else tries to make fake Spanish? Fine. Okay, anyway. Okay, so what do we do when our data really doesn't fit very well in a dot plot? We make a box plot. Okay, but we're gonna make a box plot based off the calculator because we're lazy. Shh. Okay, so everyone in the room, go to L1, clear out your business if there's stuff in there, and put all of these numbers in. Make yourself do it. It'll wake you up. 4.53, 5.04. I'm kind of a little worried about the location of the 6.38 DO and my little squid friend over here. All right, so I have 15 numbers in L1. Okay, when you're ready, go to second, and then y equals, which is the stat plot. You want to get to this screen, second, y equals. Okay, and then hit enter. And you want to turn it on. And you want to go over to the one that looks like a box plot. But I'm a really lazy human, so I'm going to choose the one that has the little outlier dots. It'll tell me which ones are outliers because I'm lazy. And then when you change it to that, it'll make your X list L1. Make sure that your X list matches whatever you typed the list into. And then go zoom 9. Zoom 9. Uh-oh. Oh. Zoom 9. Okay. Does anybody need me to run through that again? Yes? What? It shouldn't have one if you once you select the box plot, it should take that off and it should just be X list. No? Oh, yeah. Now it's selected. Okay, and then Zoom 9. Okay. All right. Okay, so Zoom 9 and then hit the trace button. And the trace button, and if you hit the left and right arrows, it will tell you where the box plot labels should be. Do you see how our minimum is 2.87? Okay, so I'm gonna start my box plot, my axis at 2.5, and then I'm gonna look here, 6.38. So I'm gonna go by 0.5s. Okay, so 2.5, 3, 3.5, 4, yeah. Oh, sorry. So I made an axis. The thing about these is you have to make sure your axis is equally spaced. And then I hit the trace button and I scroll back to the beginning. So it gives me the minimum of 2.87. So I'm going to put like a vertical line at 2.87. Scroll over 4.13, 4.83, 5.5, 6.38, and then connect, connect. Okay. Now we need to go back into the calculator to get a couple of values. So these are the things you need for the t-test. And what I'm going to do now is one variable stats to get x bar. So stat, calc, one variable stats. Make sure that it's the same list that you used when you type them in. And I need two numbers out of here. I need x bar and s sub x. X bar 4.77, s sub x 0.94. Let's go with. You guys see where I got these numbers from? X bar 4.77, S sub x 0.94. Are you with me? Okay, now what is the mean? We declared what it was at the top of the problem. 5. You always get that from your null hypothesis. Okay, and then what is n? Square root of 15. Okay. So 0.94 divided by square root of 15, 0.243. Okay, do you guys know where I got this formula from? S sub x over square root of n. Okay, and then do you know how to find a test statistic? Didn't I write something on the yellow sheet in the video? Z or T? Okay, what will it be in this problem? Z or T? T, why? Means, yeah. And the real reason is because you don't have population standard deviation, but you're not going to, so it's means. Okay, so T equals statistic minus parameter over standard error. Make sure that you hit enter here. Okay, and then p-value, T cedia. This one's negative, negative infinity, negative 0.947. Degrees of freedom, 10? No, 14. T cedia. Conclude. Since our p-value of 0.18 is greater than 0.05, we fail to reject the hope. So sad. I hate failing. Oh, actually, I don't hate it in this case.
Bless you.
Okay, we do not have convincing evidence. Come up here, start copying off the problem that aquatic life is at risk in this stream. Who knows about other streams? I guess that's a good conclusion. I mean, I don't guess. It is a good conclusion. Yep. Did you guys see there was multiple copyings and pastings? Multiple gluings and cuttings and pastings and cuttings and tapings and artsing and craftings. So next thing is the next one about pineapples. Find the one about pineapples. That's next.
Pineapple farm.
About pineapples.
Not even an A, somebody I wanted to check. I would really for
when it is actually less. My font. Interesting.
Albert, did you stand, question C below that, or do
Okay, so C it's gonna be like this. Does that make sense?
thank you.
Nope, there's a D. Neither of them are super terrible or anything. Also, isn't Maui making everything better? I love him. Is it what? No, it's a sticker. No, it looks 3D, you're right.
You know what? You need. The bucket matters. Sidebar, sidebar.
Okay, you guys, so once you get this situated, I want you to, in your groups, read the problem. State the hypotheses, define the parameters, and state alpha. You got it. I will put the answers up in a couple of minutes. Okay, that should be plenty of time. Here's the answers.
I was correct.
Mean is 31. Mean is not equal to 31. the true mean weight of pineapples from this large field. Alpha 0.05 because you use that whenever they don't say one. Anything you want to ask or suggest might also work from what I did. Okay, next. In your groups, please check the conditions. Go ahead, you got this. Guys, conditions, please and thank you.
Yeah.
Oh, you're faster than me. All right. Here it is. Randomly select. N equals 50 is less than 10% of all pineapples from this field. Large counts, N equals 50 is greater than or equal to 30, so CLT apply. Any questions about that? Okay. Now put C in if you have not already. Alrighty. So before we move on, this is a very easy question to answer, but before we move on, we need to talk about the numbers that are in this problem and not just gloss over them. This could be very easily glossed over. But there's something very important here that we need to make a connection to. This says a 95% confidence interval, okay, you're like fine, whatever, that's fine, this is about it. Blah, 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 based on the interval, significance level of 0.05. I don't want you to go in your mind, oh, well, 95% confidence, everything left over is 5%, yada, yada, that means alpha is 0.05. That is not always true. It is true if the problem is two-sided or two-tailed. Okay, I'm gonna do something unprecedented and draw a picture on the whiteboard. Try not to have a heart attack. That's so unlike me. Okay, so in this case, we have my thing, right? My thing. And then, okay. Okay, we're good, we're good.
Yeah, we're good.
Okay. Now, what that thing is this is 0.025 and this is 0.025, which makes sense because our problem is not equal to units. This only works because our problem has a not equal to in it. Okay, because not equal to means two-tailed, and so it needs both sides, not just less than or greater than. Let's talk about the difference. let's say we had a different problem that was 95% confidence interval. And this is gonna be weird, you wouldn't really have this often. But the problem was a less than instead of a not equal to. This side would be 0.025, so your alpha level would be 0.025, not 0.5. Because the less than is only the one side. You don't really roll with a 0.025 alpha level very often. I don't know if we've ever used a 0.025 alpha level. But, let's do something that would be more common. This is a much more common situation. If you have a 5% alpha level, then you have confidence interval would be 90 if there was one side. So you can't just be like, don't just gloss over those numbers. You have to give it a second of thought. This one happens to work out because it's two-sided or two tails. You can't just run that over. The nice thing is your book does most all of them as two tails. So you can kind of assume that most of the time, but I just want you to be smarter than that. It just like have that little click of thought that, oh, is it really everything else? Yes, if it's not equal to. Okay, anyway, now moving on to the very easy question to answer. A 95% confidence interval for the mean weight of this year's pineapples is 31.225 to 32.616. Based on this interval, what conclusion would you make for a hypothesis test? Since. What number am I looking for? Let me ask you now, what number am I looking for? Huh? 31. Whoa, I just tried to write the word whole without the H. Whoa, since the wool. Okay, you guys remember back to the chapter 10 test where I asked you what's the major reason that a confidence interval is better than a hypothesis test? What was the answer to that? Yeah, gives you a range of plausible value. I want you to notice that I did not do the do step for the test. But I was able to get my answer for convincing evidence from the interval, and I got a nice range of values. I still got my yes or no answer I was looking for, but as a bonus, I also got a range of what it could possibly be. That's why confidence intervals are superior. You will not see them as much as you see hypothesis tests in research studies though, and I can't figure out why. I guess people like the yes or no. But anyway, just wanted to tie that back to this. Okay, last thing, we have a D and then we're done. I'm really sorry. I know this was long and you're tired. Last thing. Okay, what do you think? Yes or no? I love you. You can make a pretty good guess if all of the variables remain the same, that they increased because of the irrigation system, but it could have been more sun, could have been fertilizer, it could have been any number of confounding variables. Nice. I said something about confounding variables today. Oh, my family's having an argument about what the best sandwich store is. I'm with you. But we yeah.
Have you been to picnic?
No, I don't know what that is.